All right, this is a very important example because the math is going to be a little bit more complicated on this one. Well, let's see what we've got here. We've got this right triangle. We have a side labeled as 2. We have a hypotenuse not labeled and an adjacent. And here's our reference angle. What do they want this time? The instructions simply say find BD. Well, what does that mean? Here's BD. They're asking for the length from B to D. They're asking for the hypotenuse. So I'm going to label that. What did they give us? From this angle, they gave us this side over here. Since it's all the way across the angle, we're going to label that as the opposite. We check our notes for the trig function that uses opposite with hypotenuse, and we come up with sine. The definition of sine is using opposite and hypotenuse. So let's go ahead and write that down. The sine of the angle, which angle? 34-degree angle, is equal to the opposite side over the hypotenuse. This time, our unknown is the hypotenuse. And that's what makes this one more challenging. Because so far, all we had to do was multiply by both, by a number here, and we could cancel it out. Doesn't work this time. The 2 is on top. So if I try to divide by 2, although that would cancel, my x is in the denominator. That's still a problem. So here's what I recommend, one method. What you can do is simply place the other side over 1 and multiply. Let me write that down. Cross multiply. Now that is a trick or a shortcut. Whenever you with a fraction and you want the fraction to disappear, if you cross multiply, you're rewriting the equation so that the fraction is rewritten and gone. So here's what I mean. 2 times 1 is 2. You put equals this times x. So the sine of 34, that's the object that you're multiplying with x. All you're doing is rewriting. Don't overthink it. You've got these two fractions, and if you cross multiply, there's no longer a fraction there. Now it's a linear looking equation, and we can proceed with very easy algebra. In other words, trying to get x by itself, well, it has something multiplying by it, so I would divide. What would I divide by? The thing that I want to cancel. So I'm going to divide by the sine of 34 degrees. I'm allowed to do that as long as I remember to do it to the other side as well. So x is by itself, and it equals whatever 2 divided by the sine of 34 is. And again, our calculator comes to the rescue. Now this can get a little tricky because when you type it in, the calculator, they're all different, and some of them need parentheses and all this sort of a thing. So you kind of have to experiment to see which steps are appropriate for your calculator. Let me just try it and see what happens. I'm going to type in 2 divided by, oops, let's clear it first. 2 divided by parentheses. See, it's not working. So what I'm going to do is I'm going to ask the calculator, what is the sine of 34 degrees? That I can do. So I say 34 degrees, and then I hit the sine button, and I get 0.34 559. And it goes on. The further you go, the more accurate it's going to be. But what I can do now is just type, okay, what's 2 divided by this decimal? And so 2 divided by 0.5591, I get 3.57. Rounding that to the nearest tenth is 3.6. Now let's look at our picture. Very important since this one was more complicated. We're saying that x is 3.6. Let's find that on the picture. X is our hypotenuse. We're saying that this side is 2 and the hypotenuse is 3.6. It seems reasonable. It's certainly longer than the other side. And it is correct. And that's how you do a more complex example. And that's whenever the variable is in the denominator, consider cross multiplying and solving that way.